Hey class, welcome back to our science class and welcome back to our energy transfer and transformation book. Today we are getting into chapter 5. So if you haven't watched chapters 1 through 4, please go back and watch those because those will build up and be able to help you better understand what is going on in chapter 5. Chapter 4, we talked about how energy is transferred from object to object or place to place. We had some examples of you pushing your friend on a skateboard. The person on the skateboard is at rest, meaning not moving, but you using your muscles and transferring energy from you to them on their skateboard, they start to move. We also had the examples of light. When electricity is transferred to a light bulb, the light bulb turns on and the room is able to go from dark to light. We talked about sun transferring energy through heat, and then also water being used as it flows through a river or a reservoir through a dam. The dam has equipment and tools to be able to capture that motion energy and to store it as electricity and to transfer that electricity from the dam through power lines to places such as our home, business, or schools. So now in chapter 5, we're going to learn about how collisions transfer energy. And maybe you don't know what a collision is. We'll talk about that as we go through the lesson. So let's first call attention to our big question. And let's read this together. How is energy involved in collisions? All right, so as we read, we'll learn about what a collision is, and then let's look for ways that energy is involved in those collisions. All right, so everybody, clap your hands. When one hand hits the other, your hands collide. Colliding, right? Those hands are colliding. So let's pause. That's our first definition. As a reminder, please use the definitions from the book as you fill out your vocabulary assignment. And then with the big question, please do not copy and paste and answer anywhere. Please use your own words. So collide. Let's read this together, Elena. To come together with impact. Our hands are coming together and having an impact. All right, so now let's lift our foot and then stomp down to make it collide with the floor. Okay, so our foot is impacting with the floor, colliding. All right, now if you have two cars, you could roll two cars down ramps towards each other and watch them bang into each other. Now that's a collision too. All right, so now let's pause. So we learned what colliding means. What is a collision? Let's read this together. Who should I call on? Mason. Okay, so Mason. Collision is an instance of colliding. So two things coming together with an impact is a collision, right? So those two cars coming together and colliding is creating a collision. So a collision happens when two objects make contact. And every collision changes occur. You might see objects change the speed, direction of motion, or even change shape because of a collision. You might hear a sound or see sparks from objects colliding. You might feel an object colliding with you. Okay, so when we clap our hands, you can feel the results of collision, right? We hear the sound, we can feel our hands hitting together. Sometimes if we clap too hard, it kind of stings. Those are results or changes from two objects colliding and creating a collision. Okay, collisions involve changes in motion. Moving objects have energy of motion, and in any collision, at least one object is moving. Okay, so in any collision, right, at least one object is moving. So we know that energy is involved in collisions because collisions result in changes. We always know, and we've talked about this in previous chapters, we always can have evidence that there's energy involved because of changes. Energy causes changes. All right, so let's learn about some more collisions. So a bowling ball has motion energy as it rolls along the lane toward the pins. What happens when the bowling ball crashes into the pins? As long as you throw the bowling ball well and it hits the pins, right? What happens? Can you predict how the pins will change? What happens, right? They fall down. Some of you guys are already saying that. Before the collision, the pins are sitting still and not moving. The collision with the bowling ball changes that. The ball strikes the pins or collides with the pins, and some of the ball's energy of motion transfers to the pins. This makes the pins gain motion energy and leaves the ball with less motion. The collision between the ball and pins also produce a loud noise, a crash, as long as you're throwing it hard enough, right? As long as you have enough motion, energy, enough speed to cause that change, a change in the form of energy from motion to sound. So what would happen if two bowling balls smashed into each other from opposite direction? The colliding balls would bounce off each other, change in their motion. The speed and direction of each ball would change. The energy of motion would cause changes during this collision. So a fun experiment next time you go bowling is try to throw the ball really light or slow so that it might hit the pin, but it doesn't have enough energy to transfer, or enough speed to transfer energy to knock the pins down. And then, as you should with bowling, try to throw it as hard as you can in a good spot to see how many pins you can knock down and see the difference between that amount of energy that you are transferring. Okay, let's read this together. And who should I call on? Daisha. So let's read this together, Daisha. What's the heading of this next section? A collision can change an object's shape. Good, thanks for joining me. So an object in motion has energy. In a collision, that energy can cause many kinds of changes, not just changes in motion. Imagine you have a lump of clay rolled into the same size as a baseball. You throw that clay hard against a brick wall, and it splats. So the collision doesn't set the wall in motion. The energy of motion causes a different change. First, the motion of clay ball stops. Second, the shape of the clay becomes flat as a pancake. I'm sure some of you guys have done that. All right, now think about the two colliding bowling balls. They are hard enough that they can roll into each other, bounce apart, and have their shapes probably remain unaffected. But think about an egg that is dropped and collides with the floor. The shell shatters and the liquid inside splatters into a mess. This is a change in shape. So not only can collisions, two objects colliding, cause changes in energy being transferred and speed and motion, direction, it can also cause changes of shape depending on how hard they collide, depending on the materials or objects that are being collided. So engineers design cars to protect passengers during a crash. Cars are designed to limit the damage to people that might occur due to a collision. Two cars hitting each other, a car hitting a building, a pole, some kind of object. The car in the picture is built so that the front part changes shape more easily than the parts closest to the passengers. So as we can see, this front is being changed in shape and smashing and getting smaller, but it's doing that so that these places around the passengers, and these are just dummy passengers, not actual people, you see little to no change right here. So this design is on purpose. Less energy from the collision is transferred to the passengers, better protecting them from injury. Okay, let's keep calling on the triplets. Tasha, what does this section say? Many collisions make sounds. Thanks. All right, again, now let's clap. Two hands collide, crash, two hearts collide, crack, a baseball and a bat collide, splat, an egg on the floor collide, boing, a mallet collides with a drum. Collisions often produce a, what's that vocabulary word, everybody? Sound, as well as changes in motion and shape. So let's pause and read this definition for a sound. So a form of energy that comes from a vibrating object. So sound is a form of energy that comes from object that is vibrating, moving. So when objects collide, some of the motion energy causes vibrations in the objects, which is causing sound. These vibrations also cause the air to vibrate. Those vibrations transfer energy to our ears. We sense this transfer of energy as sound. So sound is just energy, just what we hear. It's a form of energy that we can sense with our ears, and we sense that by hearing it. So when two objects collide, the energy of motion causes changes that result in the energy of sound. So here is a person playing a drum, and he is using his muscles to transfer energy to his drumstick to hit the drum, and then it is vibrating, and we hear that vibration as sound. Okay, let's think about space. So collisions in space don't make sound. Why? There is no air in the vacuum of space. So there are no particles of matter to be affected by the vibrations of a collision. Without matter surrounding the colliding objects, sound energy cannot move away from the vibrating objects. So if there was a crash of spaceships in space, we couldn't hear it. So speed affects collisions. We talked about how speed and energy are related. The greater the speed, the greater the energy, the greater the change. So now let's learn about how speed affects collisions. Speed is how fast an object moves. In previous chapters, we talked and learned about how the speed of an object is related to its motion energy. It is not surprising the speed of moving objects affects the kinds of changes that occur in collisions. In the game of water balloon toss, the goal is to keep throwing water balloons back and forth without breaking them. The winners know they need to toss the balloons gently and catch them carefully, kind of catching them with soft hands, kind of moving with the ball, right, to kind of slow the energy and work with it so that it doesn't just hit and collide harder to break, right? So throwing a water balloon faster produces a harder collision. Greater energy moves the balloon's motion, stretches the thin material until it tears and the water gushes out. So an object moving at faster speed has greater energy of motion than the same object moving at a lower speed. The object transfers more energy in a collision when it is moving faster than when it moves more slowly. At slower speed, there is less energy of motion that can be transferred. So as we look at these two pictures, he's just gently tossing kind of an underhand throw, and it's barely hitting it's hitting the tree, but softly because it doesn't have a lot of energy, and then it just kind of bounces on the ground. And because there's not a lot of speed, there's not a lot of energy, so there's not a lot of change that's happening. The balloon is just kind of like stretching, and then it falls and it kind of stretches. Unlike this one where he's throwing it a lot harder, he's throwing it with greater speed, which means greater energy, which will cause a greater change in the collision, making the balloon stretch out to its max and beyond, and that's why it breaks. Okay, now let's read this next section. Let's call on the last triplet, Aisha. What is the title of this section? Hope you're reading it. Weight affects the changes caused by collisions. Thanks for helping me out. Getting hit by a flying cotton ball is silly, right? It's kind of fun. Getting hit by a flying rock is a different story. The cotton ball kind of maybe tickle a little bit, but the rock could, give you a concussion, could scratch you, it could really hurt. Knock your head back, knock your body back, depending on how big the rock is. So even if the cotton ball and the rock are the same size and moving at the same speed, the rock has greater energy of motion. Why? Because the rock weighs more. So the rock has more energy of motion than the cotton ball moving at the same speed. And this goes back to our first quarter, one of our phrases or idioms that we learned, which was the greater they are, the harder they fall, right? So the greater they weigh, the more energy they have, the harder, or it's gonna hurt harder. It's gonna have that greater energy. So weight affects the energy of collisions. Each moon crater offers evidence that motion energy during collisions causes change. Objects in space, such as meteoroids, have been crashing into the moon's surface for millions of years. The heavier these moving space rocks were, the more motion energy they brought to the collisions with the moon. Heavier meteoroids produce deeper craters than lighter meteoroids traveling at the same speed. So we can see like these little ones could have been the same size of a meteoroid, but not traveling as fast, and so it barely dented the moon's surface, unlike these big craters that we're seeing as well. Okay, and that is it, guys, for chapter 5. So how is energy involved in collisions? Well, some key points, right, is talking about how the greater the speed, the greater the energy, the greater the change. And energy causes changes, and collisions are happening when two things come together and impact. That's colliding. So that is a hint and point that you should be covering in your answer to the big question. And I'll see you guys in the next lesson.